Okay, this is Pre-Cal lecture 5.6. Introduction to inverse trig. So what you're going to need for this lecture is your note sheet, and here to the, we're going to go over these bullets, but here to the right, you're going to draw some graphs in. And you're going to need your unit circle, have that handy, and you're going to need a calculator for just a little bit. All right, so let's go through the notes. So inverse trig, in order for a function, so we're on the first bullet, to have an inverse, and the way we do is f to the minus 1 of x. That's one of the ways that we say that. It must be a one-to-one function and pass the horizontal line test. You might remember that all the way back from chapter 3, how we determined whether something was a function or not. Does it pass that horizontal line test? Okay. And the basic trig functions have inverses as long as their domain is restricted. So I wrote out on the whiteboard here the same information as what's on your notes. So inverse sine, the way that you write that is sine to the minus 1 of x or arc sine of x. In calculus, we typically would say arc sine of x, but in pre-cal, we'll use that sine to the minus 1 of x, but you could see either one. What that means is the angle whose sine is x. So if you are finding the inverse sine or arc sine of x, the answer is going to be an angle. Okay? But here's the graph of sine of x. Okay, see that? So draw that out. You can see that if, this goes on forever, up and down and up and down. And if you do the horizontal line test, it fails the horizontal line test. So what we have to do is restrict it, and we restrict it between negative pi over 2, so right here, and pi over 2, right there. Okay, so if we erase that part of the graph, then you can see it doesn't, if we just restrict it to that section, negative pi over 2 to pi over 2, then it doesn't fail the horizontal line test, and it's a function. Okay, so all the answers when you take the inverse sine of something have to fall between negative pi over 2 and pi over 2. So they have to be in quadrant 1 or quadrant 4. So if they're in quadrant 2 or 3, you have to exclude it and you can't report those answers. All right, we'll do some examples. I'll show you how that works. You have to memorize this, though. You have to memorize that domain restriction for sine. Now we have a similar thing for cosine. All right, inverse cosine or arc cosine is we're finding the angle whose cosine is x. It has a domain restriction. If you draw this out, all right, pause the video if you need to, and you come back, from 0 to pi. So if we would just erase this cosine graph, which goes on forever, from 0 to pi, and that's all the part of the graph that we show, all right, if we restrict the domain to that, then it doesn't fail the horizontal line test. It doesn't pierce it in more than one spot. All right, so mathematicians have limited the answers you can give for inverse cosine to between 0 and pi. So that's quadrant 1 and quadrant 2. So for cosine, if any of the answers turn out to be quadrant 3 or quadrant 4, they're extraneous. We just will X those out, and you can't report those. All right, so we have a similar situation for inverse tangent. So pause the video if you need to. Go ahead and draw all this out, and we'll come back to inverse tangent. Okay, so inverse tangent, these bullet points, we write it as like that, tangent to the minus 1 of x, or arc tangent of x, It's the angle. So again, the answer you're giving is an angle whose tangent is x. The domain restriction is exactly the same as sine, and you have to memorize this. All right, so it's good that it's the same as sine. That helps to memorize it. It's negative pi over 2 to pi over 2. You can't give any answers outside that restriction. Again, quadrant 1 and quadrant 4 are the only places you can give answers. Now the tangent graph, and you can graph these on your calculator if you want, but tangent graph has asymptotes, vertical asymptotes, at negative pi over 2 and pi over 2. All right, and the graph looks like this. Okay, so the mathematicians just restrict it between that, negative pi over 2 to pi over 2, and then it doesn't fail the horizontal line test. Now, it goes on forever, every direction. So, you keep having those lines again and again and again. Of course, if you included all those, it would fail the horizontal line test. Okay, so we've got to memorize those 3 domain restrictions. All right, the next thing says graph all the trig functions on a graphing calculator. You can do that on your own. So take that TI-84 and try that. If for graphing inverse sine, all right, where you can see right above sine, the sine key and the cosine key and the tangent key, you have the inverse keys. All right, so graph those, give those a shot, and see what it looks like. All right, so evaluating inverse trig functions. We're here at 5.6.2. So the inverse sine of 0.5 means the angle whose sine is 0.5. Okay, so that's just an example. So our first one is evaluate the inverse sine of the square root of 3 over 2. Okay, so let's get our unit circle out. Where is sine square root of 3 over 2? And remember, it goes cosine then sine. So at 60 degrees, or pi over 3, okay, so 60 degrees, that's 1. But then you also have it in quadrant 2. At sine is root 3 over 2 at 120 degrees, or 2 pi over 3. However, you can only report one of these. Only one of these is within the domain restriction, negative pi over 2 to pi over 2. And that is 60 degrees, or pi over 3. 120 degrees, 2 pi over 3, that's in quadrant 2. That is outside the domain restriction. Okay, so you can't report that. All right, let's try another one. Okay, the next example is we want to know the inverse cosine of negative 1/2. All right, well, let's look at our handy unit circle. Okay, we're going to find where's the cosine negative 1/2. Well, remember, cosine's the first one in the parentheses. So coming around, we got one at 2 pi over 3, all right, and 120 degrees. So that one is. And it's negative 1/2 also down here at 4 pi over 3. 240 degrees. Okay, so remember the domain restriction for inverse cosine is 0 to pi. All of our answers have to be between 0 and pi. Well, 4 pi over 3 is greater than pi, so we can't report that. So the only thing we can report is 2 pi over 3, or 120 degrees. Okay, the next example, so we're going to use our calculator. It says use a calculator to find inverse sine in radians of 0.362. Okay, so let me show you, in case you're not sure, you don't remember, how to change your calculator to radians. So you go to mode, all right, and right now, I don't know if you can see this, but it's flashing normal. Go down to where it says radian and hit enter. Now it's on radians. We're going to quit that, so hit the blue key, second function, and quit. And now we're going to take the inverse sine, so that's the second function, sine. So see how it says inverse sine, 0.362. And you'll get 0.3704. So try that in your own calculator. All right, let's say you have one of the cheaper calculators, just the way where you would get, see this DRG button, just hit that. You would tab over to radians and hit enter. And if you want to find inverse sine, then hit the second button, sine 0.362, and again 0.3704. All right, so different ways to change to degrees. The next example, you can try this one on your own. We're going to take the inverse tangent. We want to do this in radian mode of negative 1.492. All right, so hit the second button, tangent, negative 1.492. I don't think you have to close the parentheses. Let's see. No, you don't. And that is negative 0.9803. Okay, so those are answers. That's in radians, negative 0.98 radians, 0.37 radians. Okay, those answers aren't in degrees. All right, let's turn the page over and do page 2 of your notes. So we're going to solve some equations for x, and our first one is 2 times the cosine of x plus 1 equals 2. All right, we want to solve for x. Okay, so the way that we solve for x here is first let's distribute the 2 here. So that'd be 2 cosine x plus 2 equals 2. Let's move this 2 over to the other side, so subtract 2 from both sides. We'd have 2 cosine x equals 0. Divide both sides by 2. Have cosine x equals 0. All right, so cosine x is equal to 0. So what angle would give us 0? Okay, so let's take a look at the unit circle, and we can see that that occurs at, cosine is 0 at pi over 2. Okay, remember cosine is the first one, so at pi over 2 it's 0. However, zeros, remember from last chapter, repeat every 1/2 of a period. So we need to figure out the period here. The period is 2 pi over the number in front of x. Okay, so that coefficient, well, that's just 1. So the period's 2 pi. So zeros are going to repeat every pi. So the way you would write this answer is pi over 2 plus, you put half of a period, which is pi, times n. That's just a short way of saying repeat every pi units, because the zeros occur again and again and again and again and again. All right, let's do the next one. I think I have room to put it underneath here. It says we're going to solve for x. And it says we have 4/3 inverse tangent x over 2 is equal to pi. So what you want to do, we want the inverse tangent by itself. So let's divide both sides by 4/3. All right, if we do that, pi over 4/3 you would flip and multiply, so 3 pi over 4. Right, we need to get rid of this inverse tangent. The way that you get rid of inverse tangent is take the tangent of both sides. Tangent and inverse tangent cancel each other out. But you have to take the tangent of the right side as well. Okay, so tangent and inverse tangent cancel each other out. You would just have x over 2. Now, what is the tangent of 3 pi over 4? Well, we know tangent is sine over cosine. So it's root 2 over 2 divided by negative root 2 over 2. Okay, so that's just going to be negative 1. Tangent of 3 pi over 4 is negative 1. Again, I'll write that up here. You're going to have root 2 over 2. That's the sine over negative root 2 over 2. Okay. So x, multiply both sides by 2. X is equal to negative 2. All right. So pause the video if you need to. And then the last section of this lecture, 5.6.4, evaluating the composition of a trig function and its inverse. So first find the value of the inner expression. So this is a composite trig function. It means we've got the tangent of the sine or the sine of the tangent, stuff like that, okay? Then evaluate the outer expression at that value. Always consider the range of the inverses. So remember, we're going to write this up here again. For inverse sine, you have a restriction of negative pi over 2 to pi over 2. For inverse cosine, our restriction is 0 to pi. We can't report anything outside of those. And then for tangent, negative pi over 2 to pi over 2. Okay, so using this, our first example is we want to take the inverse sine of the sine of 7 pi over 6. Okay, well, what is the sine of 7 pi over 6? We're going to work it inside out. The sine of 7 pi over 6, that's right down here, is negative 1/2. Now, what angles, all right, give us a sine of negative 1/2? What's the inverse sine of negative 1/2? The angle whose sine is negative 1/2. Okay, well, it happens in two places. First of all, we know it happens at 7 pi over 6. And we also know it happens here at what the unit circle calls 11 pi over 6. See how it's negative 1/2? Sine is negative 1/2, so 11 pi over 6. Both of those numbers are greater than pi over 2. Okay, or they're outside of this restriction. So what are we going to do? Well, we know for sine that our answers have to be in quadrant 1 or quadrant 4. For cosine, quadrant 1 and quadrant 2. For tangent, quadrant 1 and quadrant 4. So we know this is in quadrant 3, so that one is out. This 11 pi over 6 is in quadrant 4, but we can't report it as 11 pi over 6. We have to report it as a negative angle to get it within this. So 11 pi over 6 is the same, if you go this direction, as negative pi over 6. So that's how we have to report it. Now it fits within our restriction. Again, 11 pi over 6, if we come down this direction and report it as a negative angle, going that way instead of going all the way around to 11 pi over 6, the same angle is negative pi over 6. All right, so you'll get used to these as you keep trying them. Let's take the inverse tangent of the tangent of 3 pi over 4. All right, the tangent of 3 pi over 4, we actually did that in a previous problem, right? It's going to be sine over cosine, root 2 over 2 divided by negative root 2 over 2. So that's going to be negative 1. Okay, so where is tangent negative 1? Well, first of all, we know it's at 3 pi over 4. We just did that one. It's also negative 1. It's not negative 1 at 5 pi over 4 because that negative over negative gives you a positive 1. But it is at 7 pi over 4. You'd have negative root 2 over 2 over root 2 over 2. Okay, remember tangent is equal to sine over cosine. But on the unit circle, if you have a 4 in the denominator, 4, 3 pi over 4, 5 pi over 4, tangent's either going to be 1 or negative 1 at those spots. Okay, so that place is at 7 pi over 4. Now, can we report, so this guy is in quadrant 2. You can't give an inverse tangent in quadrant 2. That's outside the domain, so donk. However, you can give an answer in quadrant 4, and 7 pi over 4 is in quadrant 4, but can we report it that way? No, it's outside the domain restriction. We have to report the coterminal angle of 7 pi over 4, which is negative pi over 4. All right, if we just come this way, okay, if we'll go clockwise, 7 pi over 4 is the exact same thing as negative pi over 4. So that's how we have to report it. Don't report it as 7 pi over 4. And that, by the way, will probably be one of the answers on your test. Don't circle that one. Circle this one. You know that is outside the domain restriction. All right, let's do one more. And that'll finish up this lecture. We want to take the sine of the inverse tangent of 7 over 24. Now 7 over 24, that's not on the unit circle, so what do? When something's not on the unit circle, you draw a right triangle. Okay. Tangent, so this is theta. Tangent is opposite 7 over adjacent 24. Well, if you use the Pythagorean theorem, you will see that that hypotenuse is 25. It's the square root of 24 squared plus 7 squared. It's actually one of the famous triangles that a lot of times you memorize for the ACT, like a 3, 4, 5, or 5, 12, 13. 7, 24, 25 is another one that has integer numbers in the right triangle. Okay, so you can put that in your calculator, see if I'm lying to you. Okay, so what is the sine? All right, well, this is really easy. The sine is opposite over hypotenuse, 7 over 25. And that does it for this lecture. You're prepared to do homework set 5.6. And I will talk to you next time.